Hello again, students. Let's do another problem. Okay, so same charges as we had in the previous problem, and now we have arranged them so that it is two-dimensional. It's not just all on the x-axis. So we've got Q2 sitting here at the origin, we've got Q1 directly above it on the y-axis at 1, 0, and then we've got Q3 at 1, 1. What we want to find, again, is the force that Q2 experiences. So if you feel like you know what you're doing, this would be a great time to pause it and give it a shot. Okay, maybe you found an answer, maybe not. If you tried it and you got stuck, or you got an answer but you think it's wrong or whatever, let's give a few more hints here on what steps we want to use to solve this. The challenge here is really not screwing up your math, not screwing up your vectors. So I'm going to do the same first step I did before. I'm going to draw the direction of the forces on Q2. Remember, they're all positive, so it's going to be repelled by Q1. And it's also going to be repelled by Q3. There's that distance between them. This is the direction then of the force, F32. So now that I've drawn those, I can see that F12 just has a y component, doesn't have an x component. F32 has both an x and a y component. You should remember from Physics 1 or from any time you've dealt with vectors, I can't just get their magnitudes. I can't just use Coulomb's law and then add them together. That is breaking the important rules of dealing with vectors. You can't add up vectors that are pointing in different directions. So instead what we need to do is, yes, first we're going to find their magnitudes. We're going to find first F12, then we're going to find F32. But then we're not just going to add them together, we're going to break them into their x and y components. Then we can add the x components together, add the y components together, and then that'll lead us to getting F2x and F2y. And then from there, we can get that in magnitude and direction form using trig, using Pythagorean theorem and inverse tangent or something to get our angle. So let's go ahead and do that. If you wanted that hint and now you want to go try to solve the problem, now would be a good time to pause it, see if you can get the answer. Okay, let's give it a shot. Once again, I need to erase some things because it is a very small whiteboard, not designed to teach a college class, more designed for grocery lists or something. And before I do that, I'm going to give you a good opportunity, a good reward for doing this, for watching these videos and playing along and trying everything. If you are watching and you are listening to this part, I'm going to offer you half a point of extra credit on your first exam. So 0.5% extra credit on your first exam. All you need to do is email me and tell me some interesting fact about yourself. Even not interesting, could be boring. Something so I can be like, oh, this person, and get to know you a little bit, since given the weather, who knows when we'll actually see each other in class. And then I will hang on to that, and then on your first exam, you'll have a little bit of extra credit. So consider it a reward for being diligent and actually watching these and doing my little fake class here. All right, so let's erase these. Please hang on to this graph in your notes, though, because I do want to refer back to it. We're going to start by getting F12 and F32, just their magnitudes. So this should look sort of familiar, right? And it turns out all the numbers are actually the same as what we had the first time in the previous video and previous problem. And we once again get 1.35 times 10 to the negative 7th newtons. For F32, I need to be a little bit careful about what we're using for R. Remember, it is the straight line distance between our two charges. So remember on our graph, we had here's Q2, here's Q3, right? And this is at 1, 1, that's 1, that's 1. So this is root 2. So just a reminder then, I'm going to be plugging in root 2 squared, or just plain old 2. So doing that, I then get 8.1 times 10 to the -8th newtons. Now I have F12 and F32. I am not going to just add them together. That is wrong. I'm going to break them into their x and y components. F12 should be pretty easy to do that because F12, recall from our drawing, just points straight down. So F12 x is 0. F12y is negative 1.35 times 10 to the -7th. Right, just pointing straight down. So now that we have that, we're going to do the same thing for F32. We got to make sure we're using the correct angle there. Going back to our picture, we want to know the direction that this force is pointing in. I'm going to see it as this angle here, which is going to be so many degrees below the x-axis. If I want that angle, I can also notice, hey, that's also that angle. This is 1, this is 1, this is √2. So this angle here is 45 degrees. So F32 x is going to be equal to -5.73 times 10 to the -8th newtons. And because it is 45 degrees, it turns out F32y is also going to be equal to that. Right? So these numbers are coming from doing F32 cos theta, F32 sine theta, in case that wasn't clear. All right, we're going to pause here for just a second, and I'm actually going to stop this video so it doesn't get overly long, and it'll be broken into 2 pieces.